Now that we have looked at what are homogeneous functions, let's look at Euler's theorem for homogeneous functions. If u is a function of x and y is a homogeneous function of degree n, then x dou u by dou x plus y dou u by dou y is equal to nu. Remember, n is the degree and u is the function itself. Okay, let's see an example of this. What this basically means is, if this is the function x square plus y square, dou u by dou x is equal to what? 2x. Dou u by dou y is equal to what? 2y. Now we have to multiply dou u by dou x with by x, and y times dou u by dou y. Now this should give us nu. Okay, let's see. This gives us 2x square plus 2y square, 2 times x square plus y square. Now this is nothing but 2 times, and x square plus y square is f of x comma y, that is the function itself, and we know that this is a function of degree. Okay, so this was an example. Now let's see how exactly this comes about. So let's say f of x comma y is equal to u, which is a homogeneous function of degree n. Now because it's a homogeneous function, we know that u, it can be rewritten as x to the power of n g of y by x. Yes, now let's partially differentiate it with respect to x. So dou u by dou x is equal to x to the power of n as it is, and g prime of y by x, and then we have to differentiate y by x. So y by x becomes minus y by x square, plus now gy by x remains as it is, and we have to differentiate x to the power of n. So n x to the power of n minus 1, g of y by x. Okay, this is equal to x to the power of, now let's bring in minus y. Now x to the power of n by x square is x to the power of n minus 2, g prime of y by x, plus n x n minus 1 g y by x. Now let's differentiate it, partially differentiate it with respect to y. Now when we do that, what happens? X to the power of n is a constant, so we are left with x to the power of n g prime of y by x, and then we have to differentiate y by x, which is 1 by x. Okay, so which can be rewritten as x to the power of n minus 1 g prime of y by x. So let's look at, if we multiply this with x and this with y, right, what do we get? We get x dou u by dou x plus, and we add, okay, then y dou u by dou y will give us what? Now let's multiply. So minus y, x to the power of n minus 2, multiply x means what? Plus 1, g prime of y by x, plus n x n minus 1 plus 1 gy by x, plus now we are multiplying y. So x n minus 1 y g prime of y by x. Okay, so here what happens? It becomes minus y x n minus 1 g prime of y by x plus n x to the power of n g y by x plus y x to the power of n minus 1 g prime of y by x. And if you notice, this and this gets cancelled and we are left with x n g of y by x. Now here x to the power of n g y by x is nothing but u. Now here we have used only two independent variables. We could have n number of, similarly we can have n number of, so dou f by dou x1 plus x2 dou f by dou x2 plus x3 dou f by dou x3 xn dou f by xn will be equal to what? So let us say m is the degree, so m mu. There are n terms here, that means n variables, independent variables of degree m. Euler's theorem says that it's going to be degree of the function times the function itself. Now let's look at a extended version of Euler's theorem. Okay, so if u equal to f of x comma y is a homogeneous function of degree n, then x square dou square u by dou x square plus 2xy dou square u by dou x dou y plus y square dou square u by dou y square. This is equal to n times n minus 1 u. This is what Euler's extended theorem of homogeneous functions says. So now let's see how to prove it. Now we already know that x dou u for homogeneous functions of degree n, x dou u by dou x plus y dou u by dou y is equal to nu. Yes. Now the only thing we have to do is we have to look at differentiating it once more to get dou square u. So we have to differentiate with respect to x, we have to differentiate it with respect to y. Let's differentiate it with respect to x. So x remains as it is, dou square u by dou x square plus, now we differentiate x. So 1 time dou u by dou x plus y dou u by, now see here we already have dou y. We are going to differentiate it with respect to x. So dou x is equal to, n is a constant, u, so dou u by dou x. With respect to y, if we differentiate, what happens? X dou square u by dou y square. No, we already have dou x, so we are going to differentiate it with respect to y plus y remains as it is, dou square u by dou y square plus, now we differentiate y, so 1 time dou u by dou y, okay, is equal to n times dou u by dou y. Now remember we have to prove this, or we have to arrive at this x square dou square u by dou x square kind of thing. Okay, so which means what? This and what else? This is there here. We need one additional x. Okay, here we have dou square u by dou y square. Y is there. Y square is required, so we have to multiply it by y. Okay, so just based on that, let's multiply this by x and let's multiply this by y and see what happens. Okay, and in between there is a plus, so which means we have to add these two. So add these two. So let's first multiply it. X square dou square u by dou x square plus x dou u by dou x plus xy dou u by dou x dou y plus, now here we are multiplying it by y, so xy dou square u by dou y dou x plus y dou square u by dou y square plus dou u by dou y. Now I didn't multiply this with y, so y square and y. Now this is equal to n dou u by dou x plus ny or yn dou u by dou y. This implies, now we have to simplify this. Okay, so now x square dou square u by dou x square plus these two are like terms. Remember, the order of differentiation is not important. So 2xy dou u by dou x dou y plus y square dou square u by dou y square plus, now we are left with what? X dou u by dou x plus y dou u by dou y is equal to, now keep track of that number of terms, 1 2 3 4 5 6, 2 have got merged into 1, we have added these two, so 5. Okay, now here n is common, yes, so x dou u by dou x plus y dou u by dou y, x square dou square u by dou x square plus 2xy dou u by dou x dou y plus y square dou square u by dou y square is equal to, let's take this to the other side, so n x dou u by dou x plus y dou u by dou y minus x dou u by dou x plus y dou u by dou y. Now this are both, and they are both equal to what? N times, this is nothing but nu minus nu. Now which is equal to what? N is common, so n minus, no, u is one, n and u both are common, so n u, and we are left with 1n minus 1. We can rearrange it to make it, yes, so that is extended theorem of Euler's theorem. Basically the difference between Euler's theorem and extended version is that here we have first level partial derivation and here second order partial derivation. I think that's enough for today. Bye for now.